Okay, we are officially back. And we're going to have a marathon lecture. Actually, I'm going to lecture for about, hour and a half. Then we'll take another break. And then we'll go again. And then we'll get out of here. So. Software testing strategies is our next topic. And let's get through testing. Testing, deals with the concept of, and we should all be familiar with testing from the first Software Engineering 1, but some of you haven't taken it yet, so that's probably causes some issues. We have different types of testing. We have unit testing, system acceptance. What we want to do is major parts of the software project. Testing is not an afterthought. It happens throughout the life of the software project. What's going on back there? Attendance? There's way too much talking. Way too much talking. All right. Oh, yeah, make sure you do sign the attendance sheet that's going around. Some people haven't signed it yet, which is why we sent it around again. Yeah, okay. No, there wasn't. We already had an attendance sheet from earlier this morning. I know, we had a piece of paper that people were signing their names on.
Already I gave it to Prabhu. He went out.
Oh, you already turned it in?
Yeah, already we gave in the first session.
All right, so we'll do it again.
Yeah, somebody can.
If you signed the first one, don't sign the second one. Only sign your name in once. So if you signed in before the break, then you don't sign it again. These guys up front need to sign it. This guy I know hasn't signed it.
I just did.
You just did? Okay, good.
One.
All right, you're set. All right, so testing requires time in the schedule, which is why sometimes it's not done till the very end. You can't wait till the very end. It should be done at all different stages. It requires a substantial investment in terms of the processes, the time, the data. Wow, that's blurry. All sorts of different things. And good testing requires good people as well. You can't rely upon just interns to do it. And good documentation as well. In terms of the test design, you have an entire assignment in this regard. And the assignment wants you to come up with a test design, a plan, actually. Not test cases, if you remember I mentioned. What you want to do is look for, in terms of your objective, is you're trying to find the faults in the system. You can't test for dependability, can't test for safety. Well, actually, you could do safety, I guess. But the goal is you're testing whether you're going to prove that the system is correct. You cannot show a lack of faults. You can only show what faults might exist if there is a fault. So the objective of testing is to find the faults. The testing is never comprehensive, and the testing is very expensive. It's never a cheap part of the software development project. And a lot of people don't even think it's worthwhile, which is ridiculous. Well, you can tell who thinks that when you start looking at software packages with errors in it. So. In terms of strategies, we have bottom-up, top-down, stress testing. As I'm going through this, think about what it is you might want to put into your assignment, the one about testing. So you could, in your plan, you can say, well, my objective is to find all the errors possibly, or cut down on, make it reliable. And my strategy here is I'm going to do a top-down or I'm going to do a bottom-up. And to go through this really the slide goes through a lot of information. I'm going to give you the overview of it. You can download it and look at it. It's lecture 7 that goes through all of this stuff. So write number 7 down, you got it. In terms of bottom-up, each unit is tested with its own test environment. In terms of top-down, larger units are tested with dummy units. So think about the concept of you're testing the entire system. Not all of it's going to be ready, so you have to put dummy units in there. If you're starting from the bottom and working up, you don't have anything. You have to put in external data. So you can probably see the pros and cons already, hopefully, in terms of what ends up happening. The bottom-up is not going to give you any form of integration testing at all either. It's not going to show you anything about how the modules are working. It's going to prove whether the module functionalities are correct. And when I say module, these could be components, classes, modules, units. When you do the bottom-up, you're looking at the unit-by-unit module environment. When you're doing the top-down, you're looking at the user interfaces, maybe, the workflow, the way the program is running from a higher level of abstraction downward. And in terms of stress testing, you're testing it beyond its limit. In a real-time system, you're going to overload the system, or you're going to break a connection and see what happens. And you're looking at transaction processing normally in terms of that stress testing. I'm surprised that doesn't give anyone a headache. That would give me a headache looking at that. So maybe you guys have headaches. Just start giving out free aspirin here today. Slide presentations. Okay, so most of you are familiar with white box and black box. Well, this is a closed box and open box. put that on there on purpose, actually, to show you that people call it that. So actually, some people say glass box, too. Glass box is really, yeah, so you can hear that.
Yeah.
Yeah. Closed box is black box. The testing is carried out by people who don't know the internals of the system. You're testing the external interfaces. Open box is white box. You can talk about this in your assignment, actually, because I only white box and black box. Yes, it is. White box is open. Closed box is black. Glass box is open. White, open. Glass, you can see through the glass.
Yeah.
Gray box
Tinted.
is somewhere in the
Gray box is in the middle. It's like slightly tinted.
Yes.
Great.
Appreciate it.
Alright, the advantages of each of the approaches. In the case, do you want to do both? Yes.
But I have a question.
Yes.
I mean, generally we talk about the black box testing and the white box testing.
Yep.
But in industry, I mean, there are people who rarely talk about the gray box testing, but it is not a term which is defined at the level where the white box testing and the black box testing is defined. I mean, it's not. I mean, everybody is not familiar with that term.
Gray box would be you're doing both at the same time.
Yeah, I mean, I got that.
Oh,
point.
okay. But not every, you're right, not everybody's familiar with
It's
the term.
not a very.
It's hardly used either. In fact, for a while they were using glass box instead, but glass box really isn't gray. Glass box is white. So. In fact, a lot of people don't even use the white and the black anymore because it's racial. That's why they switched it to open and closed.
I see.
Yeah, it's racial discrimination in this country. Just call someone black or white or tan. You don't want to mention color in this country. No, it's either open or closed now. That's like the modern day politically correct version of it.
Well, when did this happen? Like,
A couple of years ago,
A couple of
actually.
years ago?
Yeah, not too long ago.
Yeah, because I'm not like that.
It's politically correct. It's like back when African American. But the interesting thing is now African Americans are being called African. They're not even African Americans. they're some other nationality, but they're being called that. It's like, how did that turn into? I turned into a whitey, I guess. I'm really Russian. I don't know. I'm not white at all.
Russian.
But you can't say that in a crowded room. All right, back to the lecture. Do we have any more questions about racial, ethnic backgrounds or white, black, Hispanic boxes? Russian boxes, see, they're all red. As I'm turning red. And now you can see it.
Yeah.
Ratio Down's podcast. I knew it, she was Russian. Just kidding. Alright, stages of testing. So this is another thing, we're bringing this back around to something academic associated with software engineering. And when your assignments, this is what you really want to talk about. So in the assignment, when you come up with your test plan, you got to think about the schedule. Think about when you're going to put it in, and when you're going to put it in, what kind of testing are you going to put in at each one of the different stages. And you can classify it as white, black, open, closed, whatever you want to call it, glass. If you want to say stages, testing is most effective if divided out into stages. You don't want to do it at the end, which is what the stages are referring to. And the stages actually are more particular in terms of the type and where it happens. As an example, unit testing, system testing, acceptance testing. Obviously, acceptance testing is going to happen at the end, hopefully. System testing is interesting because it can happen throughout. It can happen during, implementation, install, performance. You can look at functions. And these are different types of tests that fall into the category system tests. Unit testing is unit testing. If you wanted to, in your test plan, not to give the whole thing away, if you're talking about implementing a program in Java as an example, you could mention JUnit as a software package tool, very popular actually these days, that you could use to do unit testing during the source code implementation. It's actually best done during implementation when you're writing the code. Easier, because everything's fresh. When you start to go back after and make, oh yeah, we're all done. Let's write the JUnit test cases. I mean, it's not like test cases. You have to write JUnit. You have to actually mimic the whole thing. There's a couple of tools out there actually where you take the source code, you put it in there, all the classes and stuff, and it turns and creates your tests for you. In fact, Eclipse will automate that for you as well. automatically, a click of a button, create your unit testing for you. Not quite foolproof. Needs some editing, but it's actually not bad. So you're going to do that while you're writing it. And that's a category of unit testing. And obviously, this is not a replacement for a full class in software testing. In fact, if you're studying software engineering, this is one of the courses that you normally take. Unit testing tests a small section of the code or the system. In the case of JUnit, it's testing classes. It's a single class. Emphasis on accuracy of the actual source code. It is white or clear or glass, if you want to, whatever you want to label it. And they're driven by developers based on the understanding and specifications of the knowledge of the unit, written by developers, written by the programmers. It can be various different levels of granularity to it. Open box by developers of the unit. Oh my god, I can't even read that. What does it say over here? If unit testing is not thorough, system testing becomes almost impossible. And if you're working on a project that is behind schedule, do not rush the unit testing. Everyone likes to rush the testing. System and sub-testing would be another category that you want to add into your plan, because the plan should have everything. So a little bit of this, a little bit of this, a little bit of this. Now, if you just did unit testing, it's not going to cover this part of the program in terms of its characteristics, the subunit, and the unit. So they test the components of the complete system, combining the units together. Because this unit might work, this unit might work, put them together, oops, don't work. Because the connection in between. So the emphasis is on the interfaces and the integration and the communication that's going on. It's carried out systematically, adding components. Every time you add a new component, you've got to go back and system test, which is why this can be automated. This, if given the correct environment, can also be automated, but more difficult. Depends on whether it's a networked environment, depends on the type and nature of the application. If it's like an ATM application, that actually can be automated. All you have to do is flip the switch on, turn it on, see if the module is recognized, see if the module is working. And you have to run it all together anyway, so you have to actually simulate. So you can do this with a top-down. You could do this with a bottom-up. So if you're going to talk about top-down, bottom-up, you might as well mention as well what kind of test cases, I shouldn't say test cases, what kind of test designs are you going to implement for each one of the different approaches that you might select to take. And so in here we have closed box or open box. So I guess you could call this gray, because you could do both, open and closed box at the same time. And what does that say? System testing is finished faster if each component is completely debugged before assembling the next. Yeah, actually that's a good point as well. I like some of the little points on these slides because it's like, hello, no-brainer. Yeah, that works. Acceptance testing, as I mentioned before, on the bottom, the end of the project is when this usually happens. It's closed box. It's usually by the client. And in fact, QA people can come up with this stuff. In fact, people can come up with most of the black box testing that's being done. Because you don't have to know anything about the internal workings. In fact, you could do this right at the requirement stage. Right there at the beginning when you know the customer's going to want this, the customer's going to want this. These are all the requirements. Take all those requirements, put them in the black box test cases. And that's when I can use the word. That's when I can actually say the word test cases. Because that's what you're going to get. You're going to get use case scenarios, test cases, all of the popular, which everyone loves to do testing, shows up here because that's the easiest kind of testing.
I think UAT is mostly done by the VA. In my environment, I do that. Like we have iteration, and every time piece goes to the user for feedback and end of that iteration, they come back to us. And before that goes, we do the testing platform. We just feed values and see.
Yeah, you feed it values and see what happens. Easiest form, not quite as complete. It doesn't tell you anything about where the bugs are.
No.
Just tells you what's broken. Great for acceptance testing, actually.
Yeah.
Great for the whole system as a whole. You can use real data, you can use fake data, you can make the data as realistic as possible. And our blue quote on the bottom, the acceptance test must be successfully completed before the new system can go live or replace the legacy system. Yeah, sounds like a no-brainer. So completion of the acceptance test may be a contractual requirement before the system is actually paid for. So you can build that in as well. That's a good point. Variants of acceptance testing, we have alpha, beta, and parallel testing. So you can come up with a test plan, actually release your product in alpha. No, probably not. Beta, most likely. Alpha is pre-client, so the clients operate the system in a realistic but non-production environment. I like to use the word pre-client, and that's not really that's not PC either. Development eyes only, not out at the customer's location. When it hits the customer's location, that's when we have a monitored production environment, and then we go to beta routes. Everyone says, oh, it's in beta testers, beta routes. Most of the software today is beta, even though it's real software. You think you're buying, it's really beta.
Yeah.
They're waiting for
It's
you to
testing
find
it.
errors. You're the tester. You're not getting paid for it. You're paying them to test the program. That's how it works. That's how it should work in the real world, right?
It's agile. I mean, that's how everybody wants to do it. They
In
want
the
to
old
release
days, it was the other way around. They used to pay you.
That's
Yeah, they used to give you tickets to baseball games and stuff,
Oh,
and
wow.
coffee coupons, and all you had to do is tell them if you found any bugs. And then you got a free version of it when it came out. Now it's like the exact opposite. You got to pay them to use it,
Exactly.
and eventually you're never even going to get anything out of beta because it doesn't make it that long. It doesn't stay in the market long enough. Parallel testing, the clients operate new systems alongside of the production system. That you don't see very much. That's really hard. Because what are you going to, if a client is using a payroll system, are they going to run payroll twice? Are they going to do anything twice? No. Oh, now I see the advantages of being in this room. Basketball court next door. I just hope the ball doesn't go through that door. All the exciting things about moving into a new building. You hear the neighbors. Hey, what's going on? I didn't know about that before I signed the lease. Test cases, everybody's favorite word. Yes, I'm sorry, go back to here.
Yeah, just run back over.
You can download the slides so it's lecture 7.
Okay. Yeah, I mean, I'm just wondering because this is the first time
Who
I'm
let you
doing
in here?
parallel testing.
I'm sorry.
So you're doing it parallelly, like sending.
You have the system that's in production that they've been using and love, and you have the new system that they don't really want to change over to. You have both systems running in parallel. You're putting the data into both systems, doing everything twice, and comparing the results. And then what ends up happening is someone's going to use one or the other, and then you have to combine the data eventually.
Right.
Or it's just twice as much work. Not very good for the user. If you're talking about risk and risk assessment, which we covered actually in the first part of this course, first meeting, you're doing parallel testing to avoid risks, to reduce the risk. Because if you could do a direct cutover, you take the old system out, put the new system in, and there's a problem. Yeah, it's kind of like the EMS.
Is it done on different versions of the same product? Can it be done?
Yeah. Same product, different versions of it, yes.
But
In
I
fact,
think generally, I did not hear much about the parallel testing.
you're not going to because nobody likes it. It's not a preferred method. If you're running a banking system, it's preferred. When you need 100% reliability, dependability, going back to those concepts, and you can't afford to have a problem. It avoids risk completely. It reduces the amount of risk associated. You use that in your risk assessment plan. It totally avoids the concept of there being something that can't be turned back or over or not captured, no lost data. It's done in parallel because you're doing twice the amount of work. But it's not necessarily good for the customer or the development people either. You have to merge all that data eventually. Or toss out half the data because you got twice as many transactions to deal with. Test cases, specific tests that are chosen because they are likely to find faults, hopefully. Test cases are chosen as a balance of to balance the expense against the chance of finding an error. And that's when we talk about coverage when we talk about test cases, because you can come up with millions and millions and millions of test cases. And then you pick ones from different areas to run them so that you can cover the entire span of the program functionality, but run as few tests as needed, hopefully. And if these all pass, then you know this whole section might pass, and it's a big chance to take. If these are starting to fail, then you run them all and you see which ones are failing as a strategy. And you can talk about that in your test case plan, in your test plan. So the cases are chosen by the development team. Experienced outsiders and clients will be effective. In fact, inexperienced users are the best. And it's chosen by inexperienced will find the other faults. Inexperienced people find everything. The people who are closest to the programming don't find a thing. They never find any errors. It's the people who buy the product at Fry's and take it home and install it on their computer that find the errors. Coverage of inputs. This is where I keep talking about coverage. The objective is to test all the classes of inputs. So not only do you have program coverage, where you're testing the features, you also have the concept of input. So you have a high, a low, you have ones that are close to the threshold, that are good values, bad values, and you have...
Mutation testing, something like that.
Excuse me?
Mutation testing.
No, not mutation. It's you come up with different classes of data and ranges of data, valid, invalid, and you get things that are close on the range. Like if it's boundary testing. Boundary values, yes. Testing the boundaries, making sure you can go up to a certain limit, down to a certain limit. Yeah, because you don't want to pick something right in the middle. Never finds any errors at all. So this, the objective here in terms of the program is to test all the functions of the entire program. Paths through the program, dynamic program analyzers can actually do that. They have programs that make a flow chart. So you take your source code, you slip it in. This is an automatic testing procedure actually that does black box. And with using white box, which is interesting because what it'll do, well, it's actually gray. It's gray because you're combining both techniques. You take the source code in and it gives you paths, and then it goes through to make sure all the connections are there. If any connections are lost, then you know you have a loop that's uncontrolled. You know, it gets stuck here. It stays, doesn't go anywhere else. Some of these are graphically displayed. Some of them are just statistics. You read a printout and says, uh-oh, problem here, likelihood of a problem. And it's basically all statistical. It's analyzing the program, the flow. Statement analysis, branch testing as two concepts. So it's every statement and every branch is tested. Is the program correct? No, may not be. What about the inputs? What about the outputs? What about all the other things? It's just one form of testing, one strategy. Statistical testing, another form that you might want to put into your plan, determining the operational profile of the software, selecting and generating a profile of test data, applying the test data to the system, recording the patterns, and then finding statistically 95%. In fact, this is what a common statistic they say. You know, it's like 20% of the code ends up with 95% of the problems or something. Yeah. So you're using a statistical analyzer to come through and compute, given the complexity of the code. Your problems are going to be right here. Your problems are going to be right over here. But always the problem with statistics is they always prove wrong in the end. Sometimes they go, oh, it's just a typo. Oh, it's just the name of the class was spelled incorrectly. Okay, all right, so advantages, you can test very large numbers of transactions. If you're using statistical kind of things. You can test with extreme cases, high loads, restarts, disruptions. You can repeat after the system modifications are done. It's great for what's called regression testing, testing again, making sure you haven't broken anything through a dominoes effect. And disadvantage, uncertainty in the operational profile, unlikely inputs. You're not testing a huge range. Expensive, can never prove high reliability because you don't know the statistics. Left to interpretation. Regression testing is one of the key techniques of software engineering. It's in bold and highlighted in caps. And it's actually very important. Unfortunately, nobody likes to do it for some reason. I don't know why people don't regression test. So, and it's on your exam probably. No. What?
Yeah.
You have to retest the whole thing. Who wants to do that? Especially if it's not automated.
Actually, because that is very important.
It is very important. It's the most important part of testing. You can have a flawless program, make a change, and then how do you even know? Yeah, what side effect? And they don't even call it dominoes effect anymore. You guys know what that is, right? You line dominoes up, you press one, and all goes down. That's what I mean.
At least they generally regress the most important functionality.
It's the most important part, yeah. Applied to modern software development to provide the confidence and modifications behave as intended and do not inadvertently or adversely affect the behavior of unmodified code. So you make good stuff bad. This technique is repeated in the entire testing process after every change, however small the change. So you can put this in your test plan. Huh?
Not the entire testing process, maybe some major functions.
You do coverage, you test. You may not repeat everything.
Yeah.
And when you do it, if you're doing it correctly, You should progressively or randomly change your regression selection. So you're not doing everything identically all over again. Instead, you're picking a different, you're randomly selecting out of different groups, and you're randomly doing that once or twice.
They would say they will be highly effective areas of the
Believe it or not, with regression testing, you don't know with the highly affected or the under affected. Yeah, you changed an input for the user interface, and all of a sudden the year-to-date ratio is off. Like, how was that affected? But somehow there's like a strange side effect that occurs, but you can't predict that. So you're trying to catch what is unpredictable, essentially. So you collect this suite of cases, each with expected behavior, create scripts to run all of them and compare the expected behavior, then when a change is made, however small. You add new cases to illustrate the change, and you rerun the rest before releasing the change. Return the entire test suite all over again if you can. Obviously, you're going to exhaust your efforts at that point. In fact, testing every single piece of that software is not necessarily as effective as testing just good examples of different areas. What you don't want to do is test everything over here and don't even touch anything over here. You want to get the whole realm of features. But you may not actually have to test every number 1 through 10. You can test 1, 5, and 10 or something and skip the ones in between in terms of the inputs. You can take shortcuts as long as you do wisely. The next most important thing that no one ever likes to do is document. Documentation of the testing. Hopefully the testing should be documented for thoroughness, visibility, and maintenance. Some of you have been working in software engineering for a very, very, very long time. And you're looking at this assignment going, test plan? I've never written a test plan before. And some of you who actually do testing, I've never written a test plan before. And we don't even have a test plan where I work. Because nobody likes to write a test plan. What are you going to write a test plan for? It's like writing a business plan. Those people who don't have a business plan and go into business, good luck. Eventually they end up writing a business plan, whether they like it or not, after they've already gone into business, which is what software engineers do. After they've already made the mistakes over and over again and had all these, embarrassing mishaps that happen, well, maybe we should come up with a test plan 2 or 3 years later into the project. So the test plan, the test specifications, evaluations, test descriptions, test analysis, report. No standard, which is why I didn't give you a format for that test plan. There's no formats. If you go to IEEE, I don't know, if you follow one of the compliances, they have formats for all that stuff. But it would take you 6 months to learn the format. Once you learn the format, you probably wouldn't have enough time left over to do the test plan. So you come up with your own format. Most companies have a hodgepodge of things that people have found on the internet. That's how this works. So, the internet's great for formatting common documents. Even IT does it. So. Yeah, not necessarily. It's a new form of learning. The internet. We Google by example. Learn by Google. All right, note to user interface testing. Yes, there is a user interface testing. Needs 2 categories of testing during the design phase. User interface testing is carried out with trial users to ensure that the design is usable. Because who's going to make the same program design, unless you're Microsoft, over and over and over again? Actually, some of the things Microsoft came up with went away. I don't know. I don't like the big bubble in Microsoft Office 2010. Nobody knows it. Actually, believe it or not, all of the features are the same. The only thing that changed was the interface. But it looks like a brand new program. Acts like a brand new program. It's the same program. Has the same features. In fact, even the features themselves, they're just located somewhere else. Terrible. I think it's a terrible design, personally. I like the old feature, and I haven't upgraded yet either for that purpose. So, and during the implementation phase, you're going to do it so you can go back through the standard steps of the unit and system testing to check the reliability of the implementation. So during implementation, can we use these features? Do the features work? You're killing a couple birds with one stone. You're finding the features, and you're making sure they work. Acceptance testing is carried out on the complete system as well. Test the user interface mostly. So can the user understand it? What's wrong? I think my battery's dying. No? I'll take the computer freezing.
Oh, that one was it.
Oh, no. It just, wait a minute. Aha, see that? It redeemed itself. Whoa. It's got a mind of its own right now, though. Hold on one second. You know why? Because I kept pressing buttons. All right, let me figure out what's going on here. All right, I know where I stopped, so I'm not quite sure what's. Oh, there we go. All right. Okay, so stop pressing buttons here. See, look at that. That's what I call, what is that? That was fault.
Dependability.
That's dependability. Not only is that dependability,
Somebody forgot to write test cases.
but it self-recovered. I didn't have to reboot this thing. It fixed itself. That gives me satisfaction as a user. Where was I? Coverage of inputs, did that. Test cases, paths, strategies, statistical testing, we did that. Regression testing, we did that. Oops, documentation, user interface, fixing bugs. Lo and behold, testing doesn't mean anything at all unless you find and fix bugs. So fixing bugs, isolating the bug, understanding the bug, fixing the bug. With an entire methodology for bug fixing and a plan for bug fixing. I should say, or open source programs to track, to prioritize, to manage the entire bug process. In fact, if you take another software, well, no, I was going to say this is about it. There's no more software engineering after this class. But that could have been a good, nice assignment for you, but it was kind of overkill. I think testing is probably more relevant than bug control. But there's an entire plan that you have to go through. And moving the bugs around as well. So fixing bugs is an error-prone process, which is why the longer you maintain a piece of software, the more you fix the bugs, the more bugs you introduce, the less structural integrity you have to the entire program. It's kind of like fixing a house. Perfect house right off the market, freshly built, strong and stable. Then you start removing walls and putting in second stories and, messing around with the foundation or something. And all of a sudden the house just falls down eventually. So the longer you maintain it, the longer you fix it. It's kind of like fixing a car, same process. You're going to end up with a problem. So bug fixes need static and dynamic testing as well, because it might just be fixed when the program is not running, and then when you put it into production, it comes into a problem. Bugs have a habit of returning, coming back, as we all know. Anyone who has programming experience is familiar with that one. So security in software development process is another consideration. And so what we've got here is the end of testing, actually. That was my overview on testing. I know it wasn't very much, but it gives you some ideas to think about. If you have not taken Software Engineering 1, go back to the website, go under Software Engineering 1, read through the SE notes that's right underneath the syllabus. You'll find about 40 pages on testing, different types of testing, all stuff you can put, do a self-study on it, read through it. You can put all that stuff into your plan if you want. In fact, there's a test plan in there too. In fact, there's a risk assessment plan in there too. So that's not a bad resource for information. And in terms of security, what we're looking at is the goal of keeping things safe. So security goal is to make sure that the agents, people who are using the system, who interact with the computer system, the data, the resources, the owner of the system is basically the people who are authorized to do so and you wish to have those interactions. So it needs to be considered as part of the entire software development process. And just like the reason why it gets mentioned in here along with testing is that people wait until the very last minute to implement security. And I can summarize all these security slides with 2 or 3 words of advice. If you don't put security in from the beginning, not only does it not happen, but it becomes an overload. It adds weight to the system, it makes the system run slower, and it's added on top of the system instead of integrated into it. So if we build it into the design right from the requirement spec, then you have security considerations finely integrated. Part of the features makes the whole thing run faster, makes it more secure. If you wrap the application with security at the end, you're just going to slow it down and make it too cumbersome to work with. So it's a lot more work, and it doesn't come out as effectively. Because if you build it into the program design, you can add things like encryption to passwords. You can add things like The inability to get somewhere if you're not logged in. You can organize the code with security in mind. If it's afterwards, the easiest thing to do is break through the security layer, and then you have full access to the entire system, no problem. So, and that's why it's like amazing why people wait until the very end to think about security. It's the same way they wait to think about testing. So it has to be part of it, integrating it. Actually, that bottom quote about Windows Explorer was kind of interesting. And that it was done afterwards instead of integrated into it. Which actually is kind of the reason why Windows in general has an issue. There's no security built in, virus protection built. Those are my virus guys. It's gone. Nothing about any of that stuff that came after it. It's not built into the operating system. In fact, the firewalls that load the software, the spyware loaded on top of the operating system, it should be integrated into the operating system in a perfect design. In fact, I'm surprised they haven't done that yet. Windows 7 has got some stuff built into the Explorer and stuff. Alright, agents and components. Large system will have many different agents and components, so each is potentially unreliable and insecure. Components require third parties that may not have problems, might have known security problems. Software development challenges, develop secure and reliable components. So, I'm wondering why my computer's acting funny. Oops. I think I'm going to get done with the lecture. When we take our break, I'm going to unload some stuff that's running here. Because right now I'm pressing it to change and it's not doing anything. Alright. So I'm going to kind of skip through this. You can read it on your own. Looking at security in terms of barriers, authentication techniques. In fact, if you've taken a security class before, it's going to be a lot more information than what you have here. And if you have never taken a security class before and you are a software engineering type person, then I would highly recommend taking a security class. Because what you took in your undergrad studies, or if you've taken one 5 years ago, totally different. New techniques are out, new encryption's out. You can't password protect anything anymore. It doesn't really matter. Passwords are useless. It's third-party authentication, certificate, digital signing, digital certificates, stuff of that nature. All brand new technologies. Encryption, for every encryptor, there's a decryptor. We all know about that. Looking at security in people and in terms of people being careless, malicious, and designing security for people, not making it too much of a bother. Like 25 passwords isn't going to add that much security to the program in terms of the concept. So if you go, you can read through that stuff here. And if you go online here, you'll see some of the information systems newest updates in terms of this particular journal and what kind of security features are commonly being implemented in modern day. In fact, security is one of those things where you just can't learn about it and then think that you know. You have to go back actually and reinvent, restudy it over and over again. I'm going to start closing some stuff here because I don't know what's going on. Okay, well that was a quick run through of lecture 7. Let me just get rid of this too. I think it's my YouTube. Close Firefox. Yeah, I think it's Firefox related. Lecture 8. It's a continuation of the testing. And it's looking at software defect testing. And I'm going to just kind of briefly go over it. I won't take a break after this. I'm not going to, it's like 56 slides. I'm just going to point out some important aspects of it and hit some points that weren't covered in the first lecture that I gave you on this. And leave this for your reading. This is lecture 8, if you want to go back and read it. And it gets through understanding techniques geared towards discovery of program faults. And it really does kind of focus more upon techniques and approaches rather than the overall concept of what it is we're doing in terms of testing. Looks at the defect testing, integration testing, object-oriented testing, test workbenches, and we'll also give you some supplemental information for your test plan assignment. In terms of the process, going through, it'll break out component to integration to defect to testing priorities, which is kind of interesting. In terms of exhausting testing, so you can't actually test everything in the program. So the strategies associated with testing certain feature areas, and some of the characteristics that go into a good test design are covered in terms of the priorities. And also looking at the test data and the test cases. And this lecture actually kind of goes through and looks at how to design an appropriate test case, and how to select data that's appropriate, that's actually going to measure something appropriate for the system. And this is where you come in with the the whole process. And in fact, this might give you some designs or some ideas in terms of how to design your test cases or your test plan, I should say, for that assignment. It's going to go through black box, it's going to go through white box, equivalence, partitioning. So you have input data and output results that are supposed to be matching. So you have different sets. So you can take in different parts. So each of the classes is equivalent partition where the program behaves in an equivalent way for each one of the class members. You can kind of come out with, instead of doing everything, like 100 different features, cut it down in half and get some equivalence going on. So this is really equivalent to that. So if this works, that should also work. And it's a way of shortcutting and reducing the number of test cases to be picked. And equivalence in terms of input, valid inputs, invalid inputs, putting it into the system and coming out with the correct outputs, testing the ins and the outs to make sure that they come out with the expected results. And routines in terms of guidelines for sequences. And this is all having to do with the inputs and the outputs. So you can go ahead and read through and see all the specifications for inputs and for outputs, and how to input partition into groups. This is where you get the, finding the edge of the sample group. Let's see, what did I got on here? The system structural testing. Yeah, it's the same as white box testing, where you're testing the structure of the source code. And also called white box testing, actually, first bullet point. Derivations of the test according to the program structure. Objective is to exercise all program statements, not all the path combinations. But when they think structural is more along the lines of the statements. And here's our white box testing with our test data, our component code. I don't think there's anything, there is an example here actually with a Java program. There isn't anything and this is where you're going to see more of the equivalence class boundaries and boundary testing. So this is really good reading, path testing as well. It's really good reading to kind of go for the traditional style of testing. If you've taken a testing class, you can probably skip this particular lecture. If you're brand new, then this lecture would be really good reading for you. But I'm actually not going to cover it. I just want to make sure there's nothing in here significant that I wish to cover. The top down, the bottom up with some examples, actually, which gives you the testing approaches here with a slightly different perspective than Lecture 7 did in terms of the approaches. So interface testing, a little bit more examples. At the different types of interfaces, you could break it down. There's people who do this, actually, categories of interfaces. If you're working with a heavily interfaced program, like a network application, or an internet utility, something like PayPal as an example, has many different interfaces. So that would be very important, actually, in terms of the testing. So it would depend on the level of interfaces. If it's a standalone computer running on standalone application running on somebody's computer, you may not necessarily focus as much on this. Interface errors, looking at guidelines, and then stress testing and object-oriented testing. You're not actually required to know anything about object orientation for this class. If you do have a background in it, you will probably know already that testing object-oriented programs is slightly different, in fact, majorly different than testing different types of programs, but just because of the nature of the program, the integrity of the objects, and how the objects interact. But it goes through concepts of object interface testing and integration. Scenario-based testing. In terms of approaches to cluster testing as well. And this is basically picking out, here's an example with some weather data that's doing a sequence diagram. Test workbenches, as a concept with an example. So this is actually the end of the lecture in terms of the key points, testing parts of the system which are commonly used rather than those that are rarely executed. Not a bad thing to keep in mind. Equivalence partitions are sets of test cases where the program should behave in an equivalent way. So if you break out the coverage into equivalence areas, then you can minimize some of the testing effort a little bit. And black boxes based on the system's specification, structural testing, identifies test cases, which cause all parts of the program to be executed. And then the coverage means that ensure all of the statements have been executed at least once. Hopefully, the majority of the statements. And interface defects arise through specifications, misunderstandings, actually, errors, invalid timing assumptions. Users using the system in a way in which you never predicted them to use it. Because they can't read minds, they use it the way they think is intuitive. In fact, users will try new, interesting things, which is why we have like defensive programming techniques. So don't try to print a document that doesn't exist yet. Which is how, it's interesting how Microsoft went on, because they were the first one to do it, came out with a gray function out. If the function doesn't make sense, don't allow the user to do it. Then it cuts down on the number of errors and the number of defensive programming techniques you have to use. Test object classes, test all the operations, attributes, and states, and then test around clusters of objects that might have similar functionality. I think it's a good time for a break because my computer seems to want one. I'm going to see what's going on here, and let's take a quick 10-minute break or so, and then I'll finish up with the rest, and I'll let my computer have a break if it needs one.